But it just end with it. Oh, I just did not hear.
Come on, online.
Can we turn off our mics? Thank you. Good evening. Okay. Let's see. Yeah. So we just have two people in the house. Do we wait for them or proceed? Okay. All right. I guess it's better to just wait for them and welcome them. So, if you're joining us online, today we're going to be running through a case study. It's gonna be very impactful. So this is based on popular request. Let's do a case study, and that's what we're gonna do. So you're welcome. Feel free to chime in. Prepare your questions. That is why I'm gonna take today's very slow. It's just the last day. A beautiful gratitude to those who were part of yesterday's session. Your questions were very revealing. So just while we wait for a few more people, I'll run a few tests to make sure everything's okay. So let me know if you can hear me. Can you hear me? Just any sign, maybe in the chat. Can you hear me? Okay. Beautiful. So that works. So today is artificial intelligence for beginners. It's important that we recognize the stage that we're at and where we're going. So just because it's beginners doesn't mean that it's not something that requires some level of technical prowess, or that it's too easy. But at least it's the beginning. It's well, we'll see. So for those of us joining us, online, let me know in the chat how what your questions might be, what your concerns might be. That way we can get to involve you in the conversation as well. So without further ado, I think it's best to just proceed. Oh, I just remembered. Everybody's preparing for the election tomorrow. Yeah, it's very important. Prepare. You know, keep yourself safe. Get your PVC. Eat right. Have water. And say no to handouts during elections. Never ends well. So this is a moment. This is a moment for us. This is an opportunity for us to do the right thing, and I'm believing it's gonna happen. So, welcome. For the people who are joining us on Google Meet, they get to have the opportunity of the interactive communication. So, today we'll be picking a case study, a table data. Of course, there are different kinds of data. So while we proceed, it is best to ask questions if you're confused. And I will also do my best to provide insights at every point of the way. Don't worry, at the end of the class, I'm going to be uploading the final code for you to keep trying your hands on. From there, we can, put in more advanced whatever, but that will be next time. So don't worry about catching up. You get the code, you get the video, and every other thing. So let me share my screen first. Okay, sharing this tab. Okay, so this is us. I know you can hear me in the background, or you can see me. However, let's put something. Let's make it a little bit better, so people can see me. Beautiful. Guessing this is way to go. Put this here so we don't disturb people. So, the topic is on binary classification. The goal is to get a data, build an AI model that can classify, whether yes or no, beautiful, not beautiful, tall, short, rich, poor, just a binary classification problem. So this is an overview of what we're doing, what we're going to be doing. Okay, this is an overview of what we're going to be doing. We process the data, do some feature engineering, whatever, visualizations, normalizations, those simple things. I'll be explaining them every step of the way and why we should them. Then AI modeling. We do the AI modeling, then we evaluate how well did we do. So, as usual, prior to now, I'm assuming that the people who are joining us joined us last month. So that is the importance of being a part of the progress. It's not every time. As you can see, it's chapter 2. But the next chapter for next month, we continue from where we stopped. That is why I urge people, be a part of it on time. You don't just get to show up and then we start from where you are. No. You have to be a part of it. We're growing. So we've talked about the tools required for certain tasks on Python. Just a reminder, we're using Python. And this is Google Colab. We're running this purely online. You can see it's online. You can see collab.research. Oh, you guys can see it there. Okay, it's fine. That's the web link. I'll still share them though. Collab.research. So this is where we do the importation. And I'm going to zoom this so we have a bigger view of what we're doing. Let me, so this is where we import our libraries, NumPy for working with numbers. From NumPy, we can also import some functions for performing mathematical operations. Pandas is for working with data frames, and this OS is for path. Of course, we can also import read CSV to read a path or read a file from a folder using pandas. Glob is for capturing items in a path. Matplotlib is for visualization. SciPy, now most of the libraries here are not useful, but I'll just explain them. SciPy is for signal processing. PyWT, similar. Matplotlib, okay, this is just special functions for better visualization. Math for doing math. Seaborn for visualization. SciPy for signal processing. This is for machine learning. Seaborn for visualization. You can see it's double, so I can just erase that. sklearn for machine learning. Warnings, in case we have warnings, we can take that out. So this, I don't think we're using this for signal processing. Most of them are for signal processing. SciPy. Let me just keep working. So basically, these are the importation files. And what do we do with it? Right? We run it. So Google Colab has this thingy. So you can run it using Control plus Enter, or you can click this play button. So if I play it, see it's connecting to the Google's GPU. So when it's done, it's gonna show us a successful sign. So we can see it's successful. Look at this sign. So our journey starts here. So the next thing to do is to mount our drive and read data sets. Now, this command does it for us. So drive.mount does it. This is the path. You run it. Our path for work. You can see it's Photson Next Gen. I created a folder for that. This is where the data is. So OS helps us to change our default folder to a certain path, and that path is where we're working. So if we want to see what's in there, we use os.list directory. So if I run this with Control Enter, so it's asking for permission, right? So when you see this on Google Colab, you can see. So I have to connect. And then when I connect, it gives me access. So this is my email. I have to grant access to it. and allow. Super easy. So it's connecting. So Google Colab is very useful for people who don't have Python. They don't have all these things. You know, it's very, very useful. So you can see mounted drive successfully. So you can see the code. This is the data set. So this was for last workshop. This is for this workshop, chapter 2. So now it's time to read the data. Now, this is a data set that describes sonar chirp, returns bouncing off different surfaces. So there are 60 input variables. At the strength of the returns at different angles. It's a binary classification problem that requires a model to differentiate rocks from metal cylinders. You see, this data set is very complicated, but the goal is to differentiate rocks from metal cylinders. You can learn more about the data set on the UCI repository. You can download it, do what you have to do. So the goal is M for metal, R for rock. So a binary classification problem, that is 1 and 0. I talked about this last time. If it's a case that requires 3 classification, like 3 classes, 0, 1, 2, 5, 0, 1, 2, 3, 4, and so on and so forth. So what do? I read the data. So this is the data. And I use pandas to read it. So here it is. It says 60 variables, right? These are the variables. Each of these columns represent the variables. When you check through, you can see that there are dots here. Let's go ahead. You can see here. I don't think you guys can see there. Okay, beautiful. You can see 59, right? Well, if we start from 0, that's 60 variables. 6E, right? And these are the labels. R for rock, M for metal. So why you can't see those for metal is because I'm viewing only the first five. So if I view the whole data, then we can get to, it has over 208 rows, 61 columns. You can see here that, you see R for rock, M for metal. So, but that's not our goal. Our goal is to work on the data, build an AI model that can classify both of them. So the next thing to do is to visualize the data. So I've written a custom visualization plot that shows you all the 60 variables, those 60 columns. It shows you as a plot, as a time history plot. So that is what it does. So if you run this, that is the function. So if I put in that command, we'll see. It's now trying to run through the 60 variables to plot each of the variables as a time series. That is what we have here. So here we are. So each of them, you can see here 32, 31. So if we start from 1, 0, 1. So these are the variables as time series. You can see that somehow they're similar, but there are differences, different behaviors. Some are similar, some have different behaviors over time. And the goal is, at every instance, a combination of all these 60 variables will tell you whether it's a rock or metal. And that is this: rock, metal, 0, 1. That makes sense, right? Let's proceed. So, like I said, it's machine learning for beginners. Ideally, that data set should be worked on, it should be processed in such a way that it is useful for AI modeling. Some people are trying to join in. Am I doing the right thing? Admit. This is why I said it's important for people to join in on time. You know, you don't just wake up and just join in. You don't just wake up and join in. So I'm gonna go back to now I don't even know where to go to. Maybe this way works better. Does it work better? No, people can't see now. What I'm trying to... I want to go back to how it was before. Okay. Maybe stop sharing and then share again. Better. So, in this phase, we shall use the input features to train an artificial neural network classifier. For when I mean diagnosis, is healthy, not healthy. So it's like classification. To proceed, we do the following. We prepare the training and test data. I explained this before. To train a model, you need a data set, large data set, large portion, to train a model. After training, then you can test with a different data set to test whether what you did makes sense. So after defining those data, like preparing them, then we define the model we want to use, right? The next step is to train and validate the models using the training data. After it's well trained, then we can now test, then evaluate how well we did. Now, some of us are wondering, what is an artificial neural network? This is ideally what a typical artificial neural network looks like. A multi-layer perceptron. It has different activation nodes that push from input to the output layer. Of course, with the hidden layer in between. There are different kinds of artificial neural networks. I explained that in the previous video. If you've not watched it, kindly go to YouTube, or I think it's high time I also include a video link for Facebook for people who want to watch it. However, go to YouTube and watch it. It's important. It's a almost 3-hour long lecture series, so it's not something I will explain here. So this is an artificial simulation of how the brain works. From the input layer, it goes through different artificial neural nodes. When these A1 to A2, A23 and so on and so forth are the artificial neural nodes that connect to give you the output at the output layer. So it means that for a series of inputs, different activation processes should tell you whether it's 1 or 2, whether it's yes or no. That's how it works for multi-layer perceptron. If you're talking about things like feed-forward neural networks like long short-term memory, convolutional neural networks, they have a different method of operation. The last time we did convolutional neural network, so I believe this helps. So I would urge anyone who wants to join in to click on the FB link. Don't try to join in with the Google Meet because it's stopping us from doing what we're doing. So let's keep it going. Let me see. Okay. Okay, I can toggle. Okay, very easy. All right. So now you can load the data set. Right? Now, remember, we have a data set that contains all the information. So if we use all the data sets to train, which one will we use to test? So that's why it's always better to split it, right? Split it. So, however, we need to prepare what is the input and what is the output. Remember that everything is in one data frame, which is data.values. We can see here. Let me zoom it out so that we can see, which is data.values. That is data. So all of them are in this. Okay? So our target variables, we could make them A and B, or as they said, metal and rock. Let me write it. Metal, the liquid metal, and rock. Those are the two classifications we have, target names. So our goal is to, this is input. Isolate which one is the input variables, and then isolate the target variables, the target labels, right? That is output. The goal is to map this input to this. I just did this just for visualization's sake. So if we do that, we can see. So from the first column to the 60th column are the inputs. The last column is the target variables. So the output variable is the string values. Remember, it's in M and R, right? M and R. So we can convert them to 0 and 1 so that computer can understand it, if that makes sense. And there's something we use, label encoder. That's what we use. So when we run that, this next cell does it for us. We run it and we get it. So it moves it from strings to integers of 0 and 1. And if you want to understand what I mean, let's try to see. So if I print y, let me print this y. You can see we have r, right? which is rock, and M, meta, 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 meta. But by the time we do the label encoding, let's plot, let's visualize it. You can see we now have 1 1 1 1 1 1 1 1 0 0 0 0, if that makes sense. So we understood this part, so we proceed. So this is where we need to split the data set. We can't use all of it to train. So what we can do is we can say, let 30%, 0.3, I'll push this up here. 30% of the data be the test data set, right? And let 70% be the train data set. The train test split does this for us. So if we run this, we can see that the training input 145 variables, same 145 labels. Similar here, test, we have only 63 to test. So our goal is to use this to train. Then we define our classifier. So sklearn has different libraries for machine learning. You can see support vector machines. You can see decision trees, multi-layer regressors. There's so many. However, we'll be using multi-layer perceptron classifier. That's this MLP classifier. We can define our hidden layers, choose the number of times we want to run the algorithm, the activation function, and then solver, whether we want to use gradient descent or stochastic gradient descent. Yeah, this random state, tells us to force the algorithm not to randomize, right? So from the training data set, we choose a portion of it for validation. After validation, then we can test. If Abu is true, it's for us to see the progress. Early stopping criteria, true. So this is a little bit an advanced technique for, instead of wasting your time training a model over several iterations, you can force it to stop training when the minimum error is reached. When the model can no longer do better, it stops training. That is what it does. So if we define this classifier, we can see it's already fast, it's already trained. So you can see validation score and so on and so forth. So at every iteration, it trains. And how can we monitor? Let's have a look at this. So this is the training history. We can see that the model stops at the, let's say, 36th iteration. You see that over time, the blue line, validation score, is increasing and the loss is going down. We can say we've trained a good model because the error is low, around 0.3, and the accuracy validation score is around 0.9. That's 90 something. We can say we got a good training. We can say. So now that we've trained it, then what do we do? Our goal now is to make predictions. So remember, we have the test data. So if we predict the inputs of the test data, we should get outputs that are similar to the test labels. And that is what we compare. So if we run this, we're predicting why predict ANN is to use the classifier that we've trained to predict the input of the test data, if that makes sense. Now, there's one we call cross-validation. It's like, I want to test this. Test it several times and give me an average score of the testing over several times. That is what this does. So we want to get that result and we test. Excuse me. So we're seeing this. Gives us something. What is it training again? Okay, exactly. So it gives us our outputs that tells us, okay, this is the fit time, score time, this is a test score. 1, 2, 3. How is it 4? Okay. All right. So let me look at this. Okay. This is just for print scores. Let me rerun this so we don't confuse ourselves. 1, 2, 3, 4, 5. Remember, it's 5 steps of cross-validation. So it's saying that the first one we have 0.5, second one 0.6, third one 0.4, 0.5, 0.5 something. So it's trying to tell you that the model is around 50-something% accurate. Because if it gives you 0.5, that's 53. For here, we can say it's 54% or 53.8%. Here it is 69.2. Here it's 46.2. 50%, 58.3. Roughly 50-something% test accuracy is what we got. So let's now evaluate how well did we do. So there are performance evaluation metrics apart from accuracy. That's why when you hear me talk sometimes, I keep saying from measures of assessment. You don't just measure the validity or accuracy or efficiency of anything using one metric. You have to look at it from different angles. Then you can get to judge that particular performance critically. And that is what this does, performance evaluation. So there are different kinds of performance evaluation metrics available. And we have, of course, accuracy is part of it. There's precision, there's the F1 score, there's recall, and local metrics like confusion metrics. There are so many others. But like I said, this is a beginner course. We'll just run through these basics. So this cell, I won't go into detail into what each and every one of them is doing, right? But the goal is to test for precision, test for recall, test for F1 score. We've done accuracy already. So if we run this, so remember, we keep getting this because we put our variables to be true. So it will keep showing us the progress at every point in time. So this is it. We have for metal, precision is this, recall is this, F1 score is this, for rock, this. So this is our comprehensive report. Right? So we have a good model. Anything above 0.5, it's good. We have 0.8, 0.9, 0.6, 7. So we're good. So let's now use a confusion matrix. It's funny how it's called confusion matrix. The goal is not to confuse you, but that is the name. It's confusing, but I'll use this to explain what it does. So if we run this, we're almost done. So here we are, 0 and 1. The goal is to have a perfect diagonal, right? The true positives should be maximum, but of course there are a few wrong predictions. So we can see that for the second label, which is rock, the model is a little bit not too accurate because it predicted these 11 samples wrongly. For this, 3, only 3. So this tells us that, yes, the model is good, but it's not perfect. And that tells us more. When you build a model, it's not just about, I want to build a perfect model. These are reminders to us that no model is perfect. AI is not perfect. There are things we can do to improve it, but at this beginner level, we are assuming that we can't do those things. We just want to understand the workflow, how it works. We started from getting the data to the point where we can evaluate how much the AI model was able to solve the problem, if that makes sense. And that brings us to, towards the end of it. That's the end of the task. However, we can also want to see, how is this machine working? Let's visualize, right? So we can use some tool. There are tools to, get to visualize those things. I can use PCA, reduce them, and then try to use different models, variations of the models. So we can see here, let me make sure I have. So this is a 2D visualization of the data sets. We can see that the model is a little bit trying to tell you, it's trying to find a divide, a hyperplane, where it's going to separate the rocks and the metals. You can see that all of them are interrelated, like they are all mixed up. It's hard to find a perfect hyperplane that can separate it, if that makes sense. And that is what we have here. So we will need a model that is very nonlinear and intelligent to be able to find unique hyperplanes between the data to separate it. Like if I tell you now, draw a line that should separate blues and reds, it's going to be hard for you as a human being. But the AI model can, even to a point where it's telling you that I am achieving more than 50% accuracy. A human being may not be able to achieve that, if that makes sense. So I understand that there's network problem in Nigeria, and election is coming up tomorrow. The goal is to make sure that we have this ongoing. So with this now, we can comfortably say we've solved this problem to a significant level. And that leads us to Q&A session. So any questions so far? I'll be glad to entertain them. So, I know it's boring. It's very, very boring. Let me okay, let me turn this one off so we can. So I know it's boring, but what thing we go do? That's why I keep saying that. Okay, hands are raised. So, Victory, what's your question? Hello?
Good evening, sir. Can you hear me?
Yes, I can hear you.
Okay. My question is, okay, I wanted to know if you can will you still send us the data sets and the code?
Yes.
And okay.
Yes.
Because I would love to actually know if I can work on it too, but using TensorFlow.
Okay. Sure, it can be done. It can be done. It can be done. Sure, can be done. All right. Any other question? Oloyede Ayoluwa. I hope I got that right.
Good evening, sir.
Pardon.
Yes, you got it
Good
right,
evening,
sir.
brother.
Good. Can you hear me, sir?
Yes, I can hear you.
Can you hear me?
Yes.
Okay, bro. I want to ask if this video will be uploaded on YouTube for the sake of us that don't join in the start, so we
Yes,
can.
Sure.
Okay.
Yeah.
Okay.
I'll
Thank you so much,
definitely
sir.
do that. You're welcome. Okay. I guess it's a very straightforward. Like I said, it's beginner. And this is why I urge people. If you have this as an interest, you see the light in it. I'm doing this based on demand. Oh, I would like this, I would like that. Okay. But then it's not all rosy. It's not all sweet. AI is not creating picture online. And you say you are doing AI. You go to a website and rebrand your picture. I'm doing AI. Or you're using an AI tool to do something. Now you are an AI expert. Doesn't work like that. It's work. It takes practice. It takes a level of intellectual ability, mathematics, statistics, and other relevant areas of study for you to be able to build models, assess models, and do other stuff. So beautiful. So I'm hoping that there'll be more questions. However, this will be uploaded on YouTube for you to watch. I'm hoping that the guys here would have questions. Any questions? Are there any questions?
Yes, sir. Okay.
Yeah.
I have a question. I want to ask, what are the things you look into that made you to use like sklearn? Do you have, or how do I put it? Like, what do you use to consider first? How do you use to look at the data? Then you will now decide the type of library you will use to approach the problem.
Regardless of the library, right? You can always achieve similar results. I believe I've had this chat. Was it with you? When you're working with table data, it's always better to use sklearn, because not that TensorFlow is not better. Obviously, it's better. TensorFlow is more advanced. You get to do image processing and so on and so forth. But sklearn was designed for traditional machine learning algorithms for table data specifically. sklearn was designed specifically for table data, two-dimensional data. When you go to images, it becomes a little bit more technical on sklearn. But TensorFlow is designed to accept table data, image data, video data, whatever type of data. So cases like this, table data, I already know if it will give me more flexibility because sklearn has other dependent modules that will help me to fully work in sklearn. Because if you're working with TensorFlow, you will still need to use those dependent sklearn modules to visualize or experiment on your predictions on TensorFlow. So, if that makes sense. So it's better to know. So once I see table data, my natural tendency is sklearn. When I see anything regression problem, okay, my natural instinct, TensorFlow. Images, my natural instinct, PyTorch. So it's all, there are different modules and libraries. So it's just by practice that you get to know which ones are most befitting for this or most befitting for that, if that makes sense. I'm really exhausted. Like, you guys, you can tell I'm yawning and all that. So, but then it's okay. Do we have any more questions? I think we're getting almost to the maximum.
Yeah, that's question.
Yes, go ahead.
Okay. My question goes like this: like the libraries that you imported. I don't know
Yeah.
if it's what we are talking about. Like all those libraries, must you import every of them, or can't one work for three of them? Like, I don't know if you imported and NumPy and all those libraries are important. I want to know which one can cover this stuff. And another one.
Your voices, hold on. You're in a very noisy place. Your voice is shaky. Can you, yeah, okay.
Can you
Please
hear
go
me
ahead.
now?
Yes, I can hear you.
Okay, I was talking about the data set. Like, I don't know, while learning, if I can use the Microsoft or database, because the way those table data that you said, I don't know how to go about it. Like, if you want to set the data, did you use database or Microsoft? So I don't know.
No.
You understand?
No. I understand what you're trying to say. You want all those high level, you connect to the cloud and all those. No. That is why I said start from the rudiments. You have to start from the rudiments. There's no Microsoft anything here. It's, you're working on the data. You have the data. So why are you going to the cloud? You have the data. You're at work. Your boss says, we receive this data. Build a simple model that can show us how this data works. And you're looking for Microsoft to go to and connect cloud, and no, here's the data. You have a computer. Process it. That's what we're doing.